Hello there and welcome to another math tutorial. In this final section of our first unit of Algebra 2, we're going to look at solving systems of equations, but they're going to be 3x3 systems of equations. And that means systems that have 3 equations and 3 variables. So pretty similar to what we did in the last video with 2x2 systems. We're just going to expand on that a little bit going into 3x3 systems. Okay, let's take a look at our first example problem. Okay, this first example problem, we do have 3 equations and there are 3 variables. There's an x and a y, but there's also a z, which is kind of new. So we have this x, y, z, 3x3 system of equations. We are trying to find the x, the y, and the z, and we can put that together in an x, y, z ordered triple, similar to how we wrote the ordered pairs in the prior sections video. Now, this one is a little bit easier than a typical 3x3 system because one of the variables is already solved for. That's not very standard practice, but I wanted to kind of start us off with an easier problem. So we already have the answer for z. And because we already have the answer for one of the variables, we can solve this problem with just a lot of substitution, okay? I'm going to begin this by taking the answer for z, and I'm going to put it in to that equation's z right there. So I'm going to have 3y minus, and then instead of z, I'm going to put 3 into there, equals 3. And now we're going to solve this for y. So I'm going to add the 3 over, giving me 3y equals 6. Divide by 3, we get y equals 2. Okay, so now we've got the y value that goes with this system. All we need to do now is find the x value. So to find the x value, I'm going to go to the first equation. I can put the the z value that I started with there. I can put the y value that I just found there. And this equation would then become 2x minus 5 times the y value of 2 plus 3 times the z value of 3 equals 7. And so let's just compute this out. We have 2x minus 10 plus 9 equals 7. Put these like terms together. We got 2x minus 1 equals 7. Add the 1 over. So 2x equals 8. And x equals 4. Okay, so now we have the x value that goes with this system. Now we have the x, the y, and the z. I can put my answers together as an ordered triple: 4, 2, and 3. I don't require you to write the answers as an ordered triple like this, but somewhere in your work you should have the x, y, and the z all completely solved for. Okay, in this next example problem, we're just going to simply take it up a notch. We still are trying to find the value of x, y, and z. Okay, this one's a little bit more difficult to start because you don't have the value of any of those variables to begin with. But I do have in this one, if I just ignore the top equation, I do have a 2x2 system below it. So let's just begin with that 2x2 system. Let's ignore the top equation and let's just look like that's the problem, okay? And if that's the problem, how am I going to solve that particular system? And it's totally up to you how you choose to solve it. When I look at that, I think that the y is pretty easy to solve for because it's all by itself. So I'm just going to say y equals negative 4z plus 25. And I'm going to take that 4z plus 25. I'm going to substitute it in for y of the other equation. So I'm doing a substitution technique to solve this little miniature system here. Okay, so there's that bottom equation with the negative 4z plus 25 substituted in. We're going to distribute. We can combine the z's together, the like terms, and I'm going to go ahead and subtract the 75 over at the same time. So that's going to give me negative 14z equals negative 84. And if I take 84 divided by 14, we are going to get z equals 6. Okay, so we've got one of our variables solved for. We've got the z equals 6. Now I've got to find the y. I'm going to take this 6, I'm going to plug it in right here. So y equals negative 4 times 6 plus 25. So y equals negative 24 plus 25, y equals 1. Okay, now we need the x. And to find the x, we need to go to the beginning. We need to go to the first equation. So the first equation right here, I have 3x plus y, but y is 1, minus 2z, but z is 6, equals negative 17. So that's going to be 3x plus 1 minus 12 equals negative 17. It's going to be 3x minus 11 equals negative 17. Add the 11. So 3x equals negative 6 and x equals negative 2. Okay, so now we have the x, the y, and the z. If you want to put it together into an ordered triple, you can certainly write your answer as negative 2, 1, and 6. All right, in this next example problem, I want to take you through kind of a more traditional looking 3x3 linear system, in that we have 3 equations still, but this time all 3 equations have all 3 variables, okay? So how can we go about solving this? It's a little bit different than what we just looked at, but the first thing I'm going to do is I'm going to reduce to a 2x2 system. Okay, so that's always my first step, is try and simplify this down to a 2x2 system, because as I just did in the last problem, I had to solve that 2x2 system to begin with, and I can do that. So that's kind of goal 1, is let's try and solve this as or reduce it down to a 2x2 system. So I'm going to look at this, and using elimination, can I eliminate the x's very easily, or can I eliminate the y's pretty easily, or can I eliminate the z's pretty easily? Which one of those, the x, the y, or the z, is going to be easiest? And when I look at this, I think the z's are going to be easiest, because I already have all of them are 2's, and I even have positive and negative pairings of those 2's. And so I really like that. So that's what I'm going to do, is I'm going to try and cancel out the z's. So I like to keep my work very organized when I do this kind of system. So here's what I'm going to do. I'm going to label this equation 1, this equation 2, and this equation number 3. And what I'm going to do to start is I am going to take equation 1 and equation 2. I'm going to add them together. So equation 1 is 5x minus 2y plus 2z equals 4. Equation 2 is 3x plus 3y minus 2z equals 17. And if I add those together, the z's are going to cancel, and the result is going to be 8x plus y equals 21. I'm going to call that equation number 4. We're just going to save it for a while. So that equation has two variables, but I need to have a 2 by 2 system. So I need another equation that has the same two variables. Okay. So next I'm going to work with, how about we work with equation number 2 and 3. Okay. So equation 2 is 3x plus 3y minus 2z equals 17. Equation 3 is 2x plus y plus 2z equals 13. If I add these together, the z's cancel out. We get 5x plus 4y equals 30. And that equation is equation number 5. Now what I'm going to do is I'm going to bring equations 4 and 5 together. So we have 8x plus y equals 21. We have 5x plus 4y equals 30. That's my equation 4 and equation 5. So that is step 1. Reduce that system to a 2 by 2 system. Okay. After I've reduced that to a 2 by 2 system, now step 2 is going to be to solve the 2 by 2 system. Okay. So however you want to do that, either substitution, elimination method, whatever technique works best to solve that system. And I look at this and I want to work on the y's right here. I can take equation number 4 and I can multiply it by -4. So that's what I'm going to do first. I'm writing down here kind of what my work is. So this equation times -4 is going to be -32x times -4 is going to be -4y times -4 is going to be -84. And equation number 5, I'm not going to multiply it by anything. I'm just going to leave it 5x plus 4y equals 30. In doing this, these y's are positive and -4. They're going to cancel out. So I have -27x equals -54. Divide by -27, x equals 2. Okay, I need to now find the value of y to go with that x in this system. So I'm going to use the top equation. I'm going to say 8 times 2 plus y equals 21. This is 16, so if I subtract 16 from both sides, we get y equals 5. Okay, so that's step 2 done. I have solved the 2 by 2 system. And now step 3, I'm going to substitute to find the last variable. Okay, so I have x, I have y, I just need z to complete this problem. So what I'm going to do is I'm going to pick any one of these 3 original equations, and I'm going to put my x and y numbers into those spots, and I'm going to find the z. It doesn't matter which one you choose because they're all going to be the same. I'm going to choose equation number 3. I'm going to do 2 times the x of 2 plus y plus 2z equals 13. So this is going to be 4 plus 5 plus 2z equals 13. So that's going to be 9 plus 2z equals 13. Subtract the 9, 2z equals 4, so z equals 2. And now we have an x, we have a y, we have a z. I'm going to write my solution as x, y, z. 2, 5, 2. Okay, so there is a typical 3 by 3 system of equations. And this is generally about the amount of work that it's going to take to solve a 3x3 system of equations. I like this numbering of the equations just from the standpoint of like organizationally keeping all my work kind of clean and neat. But that's kind of up to you how you want to organize it. But this is a recommendation that I have, at least for you to do on your first few problems until you get the hang of it and things get rolling. All right, I have one more example problem, just because I don't think the one 3x3, full 3x3 system we did is probably enough to do it justice. So I want to do one more with you. And then if you need more problems after that, you can view the extra practice video that will follow this one. So I'm going to begin. I like my organizational strategy. I'm going to label these equation 1, 2, and 3. And what I need to do is figure out, do I want to eliminate the x's? Do I want to eliminate the y's? Or do I want to eliminate the z's? So that's my choice, the x's, the y's, or the z's. When I look at this, if I can find any of the variables that have a coefficient of 1, like this middle equation, equation 2's x, is a 1x, that to me makes my decision the x's. Because I can very simply multiply that middle equation by whatever I want to make it match one of the other two equations. And that to me is going to be the easiest way to go. So I am going to do this by canceling or eliminating the x's, okay? Let's begin with, how about equation number 1. And I'm just going to leave it 3x plus 4y plus 3z equals 3. And equation number 2, except I'm going to multiply equation number 2 by negative 3. So that's going to give me negative 3x. And then just be very careful you distribute properly. Multiply this times negative 3, which is going to make 6y. Multiply this times negative 3, which is going to make negative 6z. And multiply this times negative 3, which is negative 30. And then these x's, which are positive and negative 3, are going to cancel out. So we get 10y minus 3z equals negative 27. I'm going to save that as equation number 4. Okay. Now we're going to do it again to get equation number 5. And I still want to cancel out the x's. You must cancel out the same variable so that we have the same 2 left for equation number 5. So this time let's do equations 2 and 3. I'm going to take equation number 2. I'm going to multiply it times negative 2. So times this whole thing by negative 2 is negative 2x plus 4y minus 4z equals negative 20. And then equation number 3, I'm not going to change it. I'm just going to leave it 2x minus 5y minus 4z equals 31. And so here these negative 2, positive 2x cancel. We end up with negative y minus 8z equals 11. Okay, so there's our equation number 5. I hope I wrote all that large enough so that you can see on the video properly. Just a lot of work is going to go on this slide. All right, so now I have a system that looks like this. 10y minus 3z equals negative 27. And I have negative y minus 8z equals 11. That was my equations 4 and 5. Okay, so I had to figure out how I want to go about solving this system of equations. If I work on the z's, I'm going to have to multiply both equations by something, top by 8 and bottom by 3. So I don't really want to do that. I can work on this one, just multiply this times 10. That's going to make positive and negative 10. So that's what I'm going to do. I'm going to leave equation 4. And I'm going to take equation 5 times 10. It's going to give me negative 10y minus 80z equals 110. So my y's cancel out. I get negative 83z equals, and this is going to be 83. Divide by negative 83, z equals negative 1. Okay, that's the majority of the work done. We found the first variable. Now I'm going to plug it in to find the next variable. I'm going to use the bottom equation. I'll just do it right here. Negative y minus 8 times the z of negative 1 equals 11. So negative y plus 8 equals 11. Subtract 8. Negative y equals 3. So let's see if we push this up a little bit. So y equals negative 3. Okay, so we got our y solved for. Now I need the x to go with those. So which equation looks the easiest to find the x? And I would say the second equation, because there's nothing in front of the x. That looks easy to me. So x minus 2 times the y, which is negative 3, plus 2 times the z, which is negative 1, equals 10. So now over here we've got x plus 6 minus 2 equals 10. So x plus 4 equals 10. Subtract the 4, we get x equals 6. So after all that, we've got our x, our y, and our z. Our solution point is 6, negative 3, negative 1. All right, that's going to wrap up this video on solving 3x3 linear systems. If you have any comments, questions, concerns, please drop them in the comment section below. If you just would feel comfortable with a couple more example problems to watch, please look at the extra practice video that I have that follows this one. If you enjoyed the video, if you found it helpful, please support the channel with a thumbs up. And as always, I will see you in the next video. Thank you for watching.